to this Tuesday discussion. I can see that many have arrived. Must be because of our speaker, Julia Pongratz. Even though it's so hot outside, I think it's the hottest day of the year, and it's totally fitting with the topic that we're dealing with climate. My name is Christoph Mauch. I'm the director of the Rachel Carson Center, and together with Gesa Lüdecke, Dr. Lüdecke, the director of graduate programs, we are doing these Tuesday discussions, and we are alternating. And today it's my pleasure, and I have the pleasure to introduce Julia. Professor Pongratz has been a professor of geography and land use systems for quite a few years, maybe 4 or 5 at LMU. She originally comes from Munich, and she has returned to Munich, even though in between, I mean, she's living in the same building where she used to live when she grew up, even though in a different setting. But in between, she's been elsewhere. She's been in America, in Stanford and in Maryland, and she's been in Hamburg for a long time at the Max Planck Institute for Meteorology. She loved meteorology, but not enough, probably, because it was too narrow, and she ended up coming to Munich, where she, both in the geography department, you're very broad here in Munich. You have social scientists and natural scientists, but she also is affiliated with the Carson Center and is a member of our board for the doctoral students and for the students. And so she is doing research now at LMU and is teaching at LMU on climate issues. She is one of the contributing authors for the IPCC. And so it's really exciting to have you here today. It's not just lip service when you say you are really interested in other things than natural science, because I just noticed yesterday that you won one of the Teaching Innovation Awards for a course that is about a course about climate ethics. So it's a natural scientist working with a philosopher, and I think that's wonderful, and I can't wait to hear from you. I know you can talk so quickly, like nobody else. You can talk faster than I could ever think, so I hope that you can be slow, but we look forward to the next 10 or 15 minutes of your presentation.
Thank you very much, Christoph, for the kind introduction and for having me here. So it's really exciting for me to be here. As Christoph mentioned, I'm really interested in this interdisciplinary or even transdisciplinary exchange. I'm going to speak about the need for carbon dioxide removal, which is one of the measures against climate change. And then my specific topic in there is land use change, as you figured out already, and so narrow that down, given it's just 10 minutes on that aspect. This photograph already shows you an issue we're going to deal with today in the very end. It's just a close-up of land that's obviously managed, but it already shows you that most of the land is under some form of management, 3/4 of the Ice-Free Land Service, in fact, and now comes an additional pressure on this land in the form of carbon dioxide removal. But let's start slowly. So why is this carbon dioxide removal important at all? So let's look into the global emissions. These are the global anthropogenic CO2 emissions, to be more exact. On the left-hand side, you see the fossil fuel emissions, so from fossil energy, from industrial processes. And on the right-hand side, you see the fluxes associated with land use change, which is afforestation and deforestation. So deforestation would be here, emissions to the atmosphere. Afforestation would take up part of these emissions, but you see the net is we're on the positive side here. And we are on the very positive side here with the fossil emissions, of course. So altogether, if you add that up, we are at around 40 billion tons of CO2 that we are emitting each year. There's a dip here. This was the first year of the pandemic. Just to put that in relation, if we continued such a downward trend, we'd be about in line with the Paris Agreement's 1.5 degree target. But of course, we prefer to not do that with more pandemics and economic downturns. We can discuss if that's possible. It is later, but let's see. So in any case, if you look at this trajectory and if you add land use emissions, which are positive as well, we see that even 6 years after the Paris Agreement, global emissions show no clear downward trend. So in fact, we probably will see a further upward trend this year. How does that compare to what we want? Well, clearly not very well. We have a large gap to the emission trajectories that would be in line with a climate target of a global mean temperature increase over pre-industrial levels of well below 2 degrees, which is what the Paris Agreement stated, and everyone was happy with that. This is the climate action tracker. If you want to have a quick insight into how far off we are from what we wanted with the Paris Agreement, this is a good resource to go to. It's frequently updated in terms of what each country in the world promises to do. You see the emissions again here. We spoke about 40 billion tons of CO2. Now they're also adding other greenhouse gases here, so we're at around 50 or 55. So that's all consistent. And now the interesting part is the future here. And you see how the global emissions would have to evolve if you want to be compatible with a 1.5 degree target, so limiting warming to that. We need a trajectory of emissions of about that. You see where we are currently with the policies in action. So this is where we'll end up if we do what we currently already do, what we've currently implemented in terms of climate mitigation measures. So there's obviously a big gap here. But the other interesting point about that is that the actions are very different from not only the Paris Agreement's goal, but also the pledges. So we've promised much more already. When you look into the climate conferences each year, we're promising much more than we actually have in place. So this gap we need to close, and then this gap we need to close as well. So, and because there's this big gap, we're back to the emissions. Because of that big gap, now there's more talking about CDR, about carbon dioxide removal, than there used to be. The IPCC report, the 6th assessment report, and there specifically the working group 3 that deals with mitigation, states it very explicitly. The deployment of carbon dioxide removal to counterbalance hard to abate residual emissions is unavoidable if net zero CO2 or greenhouse gas emissions are to be achieved. We'll figure out what that exactly means on the next slide. So this here, let's first say that all these scenarios that are compatible with a 1.5 degree target, they include some form of carbon dioxide removal. So it's really, we're discussing that, we're already counting on that. But the interesting part here now is, and the IPCC is also very clear about that, there's multiple roles of carbon dioxide removal in this climate mitigation story. There's 3 roles, if you want to split it like this. The first is what the statement before referred to. So it said that we already committed to carbon dioxide removal if we want to counterbalance hard to abate residual emissions. Does anyone know what residual emissions are, or what emissions are hard to abate? Just think of long haul air traffic, where we have no idea if we can electrify that, where we can't, but maybe synthetic fuels, but not at the moment. Just think of methane emissions from cattle. We can reduce our demand for cattle, but as long as we've got cattle, there's methane emissions, nitrogen, N2O emissions from agriculture. Whenever we apply fertilizer, this is an issue. And that's really hard to eliminate entirely. And so, therefore, if we want to compensate for that, we need uptake of CO2 from the atmosphere. And this is because the Paris Agreement trajectories compatible with that tell us that somewhere early in the second half of this century, we need to be at net zero emissions. So you see it here for the net greenhouse gas emissions. Here you see it here if we just consider CO2, it's not important. But in any case, you see at some point we're at net zero. And this means these hard to abate residual emissions inevitably need uptake by carbon dioxide removal. So that's the one purpose. We're not going to get around that. And the surprising thing is that a lot of countries have committed to doing so because they've committed to the Paris Agreement. And so implicitly, we've already committed to CDR, and the question is now no longer if we want to do it, but how, when, and where, and who should do that. Now the other role comes back to that we're just not fast enough with getting our emissions down. And so CDR, carbon dioxide removal, is now also discussed more in this earlier time frame, where we say, because we're just not good enough at cutting down emissions, although we know how it would be doable, we just don't do it. So CDR could help accelerate the mitigation. It does not mean that we can let loose on our goals of emission reductions. This is very important. But since we're not doing very well there, additionally also we need the CDR. To not allow us to go lower on our goals on the emission reduction side, a good aspect would be to keep those two goals separate. So on the one hand, we set us goals for how much we want to reduce our emissions. And then additionally, we set us goals for carbon dioxide removal. If we're better at carbon dioxide removal, well, even better, then we're getting to net zero faster. But it should not mean that we could then alleviate our emission reduction targets. But this is not something the countries have necessarily committed to, but this is something that's an easy solution, if implemented easy, in terms of does carbon dioxide removal take anything away from emission reduction? It does not have to. And then the third role of carbon dioxide removal would be, you see in the second half of the century, we are at net negative emissions. Because we've done so poorly here, we need to make up for that later, and then clearly we need CDR even if we weren't speaking about residual emissions. Good, so much about why we need the CDR, and now what is CDR? Sorry that I didn't tell you until now, but there's a whole range of carbon dioxide removal options we speak about currently. So a lot of land and ocean-based approaches are discussed. There's a whole continuum from technological solutions to nature-based solutions, as they're called. I illustrate the most important ones here, and then we can discuss details later if you wish. So on the one hand, there's the ocean side, where you can change the ocean chemistry such that more CO2 is taken up. You can also have blue carbon, like in mangroves. That's obvious, right? It's woody vegetation, and they store a lot of carbon in the sediments that could help. You also have land-based methods, afforestation, similar like mangroves, but more in the biomass than in the soil. Bioenergy with carbon capture and storage would mean you've got these fast-growing plants. You harvest them every year for herbaceous ones, or every 7 to 15 years for fast-growing trees. You can substitute fossil fuels in your energy or electricity production, but that is not net zero emissions, but you need it, or net negative emissions. What you needed to do is then take out the CO2 from the chimney or wherever you burn it, and then bury the CO2 somewhere. Underneath the ocean, underneath the land, somewhere the CO2 needs to go, maybe in very long-lived products. Other things, enhanced weathering, biochar, I don't want to go into detail. Here's a very technological one, direct air capture, which is really synthetically you take out the CO2 directly from the air in the atmosphere. Now, there's two challenges here. So the one is, which one should we do? So we need to consider them all, and we need to evaluate all these methods against each other. And the other challenge is, so there's a lot of literature out there that shows us the technological or the technical potentials of these methods. So if we afforested the entire planet, then we can do this and that much. It's irrelevant because we cannot afforest the entire planet, and so we need to consider that there's side effects on ecology, on climate, locally on water fluxes, that there's societal processes that need to be accounted for, issues like desirability or feasibility, and also feasibility on the economic or political respect. So this all needs to be solved, this multi-dimensional problem. And now just an outlook with two quick slides on the land use issue, because I've shown you that here we've got ocean and land, but really much of ocean methods isn't doable currently in Germany, for example, because there's rules and regulations against it. And also this is something we've done for hundreds of years. Afforestation we've done for a couple of 100 years in Europe. So we think we are safe there. We know how it acts. We don't fully, but at least this is readily available. And so therefore there's a big pressure in particular on the land. I anticipate the same for the ocean later, but right now a big pressure on land. And this is the problem. So as I said in the very beginning, most of the land surface is already managed for other uses, food and fiber production, recreation and tourism and so on. This is a map by Earl Ellis. It shows you that we no longer classify vegetation by biomes, a biological term, but by anthromes, because we really don't have pure ecosystems without human interference. And when you look into wildlands, you find them really just in the very cold or dry deserts and not admittedly in a rainforest, not that much. And now on top of that comes the carbon dioxide removal at huge extents. Possibly, still a choice we have. And the other issue is, so let's just look at the current land use emissions. This is the pattern of how CO2 that relates to land use, because we clear forests to put agricultural land there in Brazil, how these emissions are traded. And so you see, for example, the deforestation in Brazil is a lot because we import soybean to Europe or to China in the last year. So you also see the changes over a decade, in particular to China. And so this is the current land use change. About a quarter of our emissions are traded. And how will this look like with carbon dioxide removal? Maybe we don't want to afforest here because we've got other things to do with our land. So we push it to Brazil, back again there. But this all interacts with the current trade flows. And so this is all getting very, very complex and up to negotiations over the next, I guess, decade. So I leave you with that food for thought, and I'm very happy to hear your view on all this. Thanks.